Hello everybody. Today we'll discuss Physics NEET 2023 question paper and let us analyze it. We'll discuss the solutions of each question and also let us have a complete analysis of Physics NEET 2023. Let us begin. We'll start. First question, you can see here the first question. Integral E bar dot ds bar equal to 0 over a surface, then which of the following options are suitable? So here E bar dot ds bar, integral E bar dot ds bar, this indicates electric flux. This expression indicates the electrostatic flux or electric flux, and here this is 0 means what? When will we have a 0 electric flux? Let us consider a surface, an imaginary Gaussian surface. If the number of electric lines of force entering is equal to the number of electric lines of force leaving the surface, which means the net inward flux, if it is equal to the net outward flux, then we can have the net flux to be equal to 0. So here the conclusion is say number of flux lines entering the surface must be equal to the number of flux lines leaving. So inward flux plus outward flux equal to 0. Inward flux E bar dot ds bar, if you split, we'll get it as E bar dot a bar, which is Ea cos theta. So the inward flux is positive, and similarly the outward flux Ea cos theta, if you consider the definition of flux, then E electric field A area into cos 180. So this is minus Ea, and here it is Ea cos 0. So here this is a positive flux, this is negative. If you add the number of electric lines of force entering and leaving, the inward flux plus outward flux, if you add, the net flux will be equal to 0. So this is the fourth option is the correct option. So this is the correct option. Number of flux lines entering the surface must be equal to the number of flux line leaving the surface. Next question. The errors in the measurement which arise due to unpredictable fluctuations in temperature and voltage supply are. So here the errors mentioned are related to the temperature and voltage supply. Temperature and voltage supply in a measurement. Not only temperature, not only the voltage supply, any kind of error which arise in any kind of measurement which is unpredictable, it comes under random error. So just this is a conceptual question and the answer is random error. This is the answer. So do remember, random errors are the errors categorized under which the unpredictable errors come under this particular type of error. Next question. A football player is moving southward and suddenly turns eastward with the same speed. So what is given here? So the player, he is moving southward. This is the south direction with some speed, and suddenly he turns eastward. This is with the same speed he turns to east. The force that acts on the player while turning. The force that acts on the player while turning. So he is turning suddenly. Because of the turn, what is the force he experiences, or the force direction we need to predict, the force direction we need to calculate. So let us calculate the force direction. So force, a vector, is mass into acceleration, a vector again. So this can be written as the acceleration is dv bar by dt, and the average force is m delta v by delta t. The magnitude of average force can be written as m delta v by delta t. So from this it's very clear that direction of force depends on the direction of delta v bar, the direction of dv bar or delta v bar. That means change in velocity direction is nothing but the direction of force. Force direction is nothing but the change in velocity direction. So let us see what is the change in velocity direction. So change in velocity means final velocity minus initial velocity, no? So change means final velocity minus initial velocity. So initial velocity, this is final, this is final, and this is initial, south initial, and this is the final velocity direction, and this is the initial velocity. So now negative of initial velocity, negative of initial velocity, this is south, na, initial velocity south, negative of means opposite. So opposite is what? So south opposite is what? North. Next final velocity, final velocity is nothing but east. So this is east. So your direction of delta V bar is nothing but it is in between north and east, so it is northeast. This kind of calculation, this kind of answering a question, it saves time. Easily you can answer. The actual method by taking unit vector notation I cap, j cap and substituting here, assuming a velocity V final bar minus V initial bar, that takes a process. It's a long process. So just listen. That is, this is the easiest way where you can save some time. Easily you can calculate and easily you can tick the option. For especially if magnitude is not needed, just direction is required. So what we are supposed to do? Initial velocity. So initial velocity, negative of it. Negative of it means south opposite, that is north, and final velocity same, that is east. So opposite to south, north, east as it is we are taking. So northeast, delta V direction is northeast. When delta V direction is northeast, then force direction will also be in the northeast direction. So the option which you can tick is key, north, along northeast. This is the answer. We'll proceed to the next question. A metal wire has a mass. Mass is given here in grams. Radius is given in millimeters. And length is 5 plus or minus 0.2. It is measured in centimeters, gram, and this one millimeters. The maximum possible percentage error in measuring the density. So density, let us see here. Density is mass by volume. So here we are considering a wire. So wire volume, I can write it as pi r square L. Basing upon this expression, density error, relative error, delta rho by rho equal to error in mass delta m by m plus error in radius 2 delta r by r plus error in length delta L by L, plus or minus. So this is the way how we calculate the relative error in density, relative measurement of error in density delta rho by rho. Now, if we require percentage, what are we supposed to do? Delta rho by rho. Percentage is this whole thing, this total into 100. So this is the way how we can calculate. But what are we supposed to substitute? Delta m. So this is the error in mass, 0.002 by 0.002 divided by 0.4 plus 2 into 0.02 by 5. So the error in radius 0.001 divided by 0.3. Like this, we can substitute each and every value easily. Next, radius error completed. Next, delta L by L. Length, so length is 0.02 plus 0.02 divided by 5. So here you can see into 100. Here the point is mass error, error in mass. This is the error in measuring the mass by value of mass. Error in radius delta r by r, delta L by L. So we just substituted, and you can simplify, you can multiply it with 100, you can get the percentage error in measuring the density, you can calculate. So we'll proceed further. Next question, all of you. So you can calculate here as far as calculation is considered. So here 0.00 to this one, as far as calculation if it is considered, 100, you multiply just 100 with it. So here it will be, this is 2 by 0.4, and here 0.001 into 100. So here 1 by 0.3, like that 2 by 5. So you can calculate, and finally you will get 1.6 percentage. The error you can get it as 1.6 percentage. We will proceed for the next question. The net magnetic flux through any closed surface is, the net magnetic flux through any closed surface is. So let us calculate. If we consider a closed surface, then do remember everybody, for a closed surface, the magnetic lines of force form closed loop. Magnetic lines of force, they are forming, they can form a loop. So something like this. The magnetic lines of force form closed loop, which means something like this. So it's like this. So it's like this. They form, they enter in, leave out. They enter in, leave out. All the lines of force enter in and leave out. So what are we supposed to conclude finally here? The flux, inward flux, the number of electric lines, the number of magnetic lines entering in is equal to the number of magnetic lines of force leaving out. So net flux will be 0. So the net electric flux, sorry, the net magnetic flux will be 0, since inward flux equal to outward flux, and net flux is inward flux plus outward flux. If you consider the outward flux to be positive and inward flux to be negative, they are equal in magnitude, opposite in sign. So the net flux will be 0. Phi net will be 0. So the option is fourth option. Next question, we'll see the next question. In an LCR series circuit, inductance is given. So inductance 10 millihenry. Next, capacitance 1 microfarad. Resistance 100 ohm. The frequency at which resonance occurs. The frequency at which resonance occurs. So let us calculate the resonating frequency. So first, in an LCR circuit, what is this resonance? Inductor, capacitor, resistor. An AC circuit, an AC source is connected to inductor, capacitor, resistor. This is the AC source. Now, when capacitive reactance equal to inductive reactance, we call this as a resonance. And if you substitute the capacitive reactance and inductive reactance, and finally you will get like this, say omega equal to 1 by root LC. This is the formula. Or frequency is 1 by 2 pi root LC. All of you just see here. This is the formula for resonating frequency to calculate. F is equal to 1 by 2 pi root LC. So you can calculate. So 1 by 2 into pi value into 1 by under root of LC. Inductance 10 millihenry, 10 into 10 power minus 3. Next, capacitance is 1 microfarad. So 1 into 10 power minus 6. And finally, you can calculate. If you simplify, you will be getting it as, after the simplification, 1.59 kilohertz. After the simplification and all, the resonating frequency, this is the value. So the key is 3. Third one, 1.59 kilohertz. And resonating frequency in a LCR series AC circuit, 1 by 2 pi root LC. 1 by 2 pi root LC. Next question. The magnitude and direction of current in the following circuit is dash. So let us calculate. Here you can see a resistor and 2 batteries. Just you are seeing here now. These 2 batteries, how they are? They are, the polarity is opposite, na? Minus plus, negative terminal positive, and then positive terminal negative terminal. So the polarities are opposite. The net voltage here, it is how much it is? 10 minus 5. 10 minus 5, that is 5 volts. Next, this remaining resistance All resistors which we have are, one is 2 ohm, next 7 ohm, 2 ohm, 7 ohm and 1 ohm. 2 ohm, 7 ohm and 1 ohm. So here you may ask, or you may get it out, like why am I taking this 2 and 1 ohm here? So this is completely, it's a series circuit. You can take this, you can consider this 2 ohm here and here. So it's a series circuit, doesn't make a difference. And here current direction is this way. This is the net voltage direction, or the current direction is from here to here, left to right. That means from A to E or A to B, whatever. So the current passes from A, it starts from A to B through E. That's the direction. Now this voltage is net voltage is 10 minus 5 volts. I equal to V by effective resistance 10, 7, 8, 9, 10. So 1 by 2, that is 0.5 ampere is the magnitude of current, and the direction of current is from A to B through E. So A to B through E, 0.5 ampere. 5 by 9, 1.5, 0.2. So that doesn't match with the obtained answer. So here 1.5 we have, here 5 by 9, here 0.2. But the required answer is 0.5 ampere as per the calculation. First option is the suitable one. E is first one. Why? Because A to B through E. This is the direction of current. The direction of current. This is the net. I am replacing this 10 volts, 5 volts with a 5 volt battery, which is the net value of these two, greater minus lesser. See here, very simple and easy questions. The questions are so easy, just by calculating few questions you can attempt, and by knowing the concept few questions you can attempt easily. We can say it's a very moderate and easy paper. Few questions moderate and majority of the questions are easy. Simply you can answer, like equivalent capacitance of the circuit shown. So equivalent capacitance, very simple. These two capacitors 3 and 3, they are in parallel. So this C parallel, how much it will be? C1 plus C2, that is 6 microfarad, and this 6 microfarad, it is in series with the 6 microfarad is in series with the 3 microfarad. So the equivalent capacitance, the effective capacitance of the two, we have to calculate. So C effective across AB is C1 C2 by C1 plus C2. This is the relation we can use for series capacitors. C1 C2 by C1 plus C2, 3 into 6 by 3 plus 6. So 2 microfarad. The effective capacitance is 2 microfarad. The option is 4, 2 microfarad. Next one, we'll proceed to the next question. The magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 ampere is dash. So first of all, in an inductor is used to store magnetic energy. The magnetic energy is expressed as half L I square. L inductance, I current flowing through the inductor. So L we have, so 1 by 2 into inductance L 4 micro, 4 into 10 power minus 6 into current I 2 square. So you can calculate here, and 8 into 10 power minus 6, here you can see 4 by 2, this is 2 into 4, so 8 into 10 power minus 6, that means the answer which we can opt for is 8 microjoules. That is a key, you can say 8 microjoules, 3, third one is the key. So this is half L I square, straight away direct question, formula based. See here, this question, absolutely no need of any thought, easily anybody can attempt. See this question, Venturi meter works on what? Which principle? Everybody know Venturi meter will come in a topic called as fluids, fluid mechanics or motion of fluids. So obviously Bernoulli's principle is the answer. So no need to think, no need to calculate, no need to analyze, straight away direct Bernoulli's principle is the answer. Venturimeter is going to work basing upon Bernoulli's principle, which comes under fluid motion. Question on radioactivity from nuclei topic. So half-life of a radioactive substance is 20 minutes. So half-life is given as 20 minutes. Next, in how much time the activity of a substance drops to 1/16th of its initial value. 1/16th of its initial value. The activity drops to 1/16. So just see here how we are going to. First, initially the fraction is 1. Means 1 means total. It's not decayed. It's not disintegrated. Now in one half-life, it becomes 1/2. This is one half-life. In two half-lives, it becomes 1/4. In three half-lives, it becomes 1/8. In four half-lives, it becomes 1/16th of the initial value. This is what we require. The radioactive sample decays or disintegrates to 1/16th of its original initial value 1. It is 1/16th. So how many half-lives it took? 4 half-lives. So 4 half-lives in the sense, say one half-life is 20 minutes. 4 half-lives, it will take a time of 80 minutes. That's it. So the answer is 80 minutes. So key is 3. This one 80 minutes. Why? Because it takes 4 half-lives to reduce to 1/16th of its initial value. So 4 half-lives in the sense, 4 into each half-life, how much time it is taking? 20 minutes. Like that, for 4 half-lives, it is 80 minutes is the answer. We'll proceed to the next question, all of you. The ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the radius of gyration of the thin hollow sphere of same mass and radius about its axis. So, okay, if you see this question, so a similar question was asked in 2022 also. So, but slightly it is different, but the question was basing on radius of gyration only. Let us see what to do with this. It's a straight away direct question. Simply, moment of inertia is mk square. So moment of inertia, what it is? First, here solid sphere, the first one. Next it is, after that it is hollow sphere. So for solid sphere it is 2/5 mr square. And for hollow sphere it is 2/3 mr square. Which is equals to the moment of inertia ratio, which is equal to m k1 square by m k2 square. I mean to say k1 radius of gyration of solid sphere, k2 radius of gyration of hollow sphere, thin solid sphere and hollow sphere, solid sphere and thin hollow sphere. So if you simplify it, 2/5 and 2/3, so 2/5 into 2/5 and this is 3/2. So it is 3/5 left hand side. This is k1 square by k2 square. So k1 square by k2 square is say 3:5. So the answer is 4th. But all of you listen carefully. There is an error in the 2023 question paper. The error is they would have asked it as a square of the ratio of squares of radius of gyration. That will be the correct questioning. Why? Because here in none of the cases root is mentioned. See, if you calculate k1 is to k2, you will be getting it as √3 is to √5, no? But square roots are not mentioned. So either you can get a bonus, or if you attempt 3:5, you may get a mark. You may get positive marks. So here the conclusion is the option has to be either √3 is to √5, or they might have asked the question as the ratio of squares of radius of gyration. So then 3:5, fourth option is perfectly suitable. So let us mark it as a key, fourth option, or bonus, any one possibility. Let us see, either key, fourth option, or bonus. Just see here, a 12 volt 60 watt lamp is connected to a secondary of a step down transformer whose primary is connected to AC mains of 220 volts. assuming the transformer to be ideal. This is the important point. Assuming the transformer to be ideal, it's an ideal transformer. What is the current in the primary winding? So if I consider a AC source and this is the coil inductor. So this is the AC source. It's a primary circuit, and just next to it there is a secondary coil, and let us have a current meter to measure the current. So now the given information is a lamp is connected to the secondary. Here this lamp is connected to secondary. This is the secondary circuit, and this is the primary circuit. A lamp is connected over here. Now ideal transformer means what? So ideal transformer means input power should be equals to output power. The input power which we give should be equal to the output power. That is the main definition of ideal transformer. So input power is a product of voltage into current. Therefore, let us take the input power we shall consider, that is 220 volts is the voltage into primary current. Input means primary, output is secondary. So input voltage into input current is power. P is equal to VI. Output power they gave 60 watts lamp has to be glown. So output power is 60 watts. Clearly it is mentioned that the output has to be 60 watts so that the lamp will glow. So primary current is supposed to be calculated. IP we have to find out. So IP equal to 60 by 220, that is 6 by 22, that is 3 by 11. So primary current you can calculate 3 by 11, you can calculate. So maybe you will get, I think 0.27 ampere you will get. So key, we can say fourth option is the key. The option 4 is the key. So 0.27, input power is equal to output power. Power is VI, output power directly given, no need to find out. This is the concept. So answer 0.27 ampere. See here, next question basing upon the thermodynamics, that is next question basing upon heat and thermodynamics branch, which is basing upon RMS velocity or RMS speeds. So let us calculate. Let us see. First here the temperature of a gas is minus 50. Temperature of a gas is minus 50. Immediately I'll add 273. It is compulsory because temperatures are taken in absolute scale or Kelvin scale of temperature. We have to convert it by adding with 273. Next, to what temperature gas has to be heated. So finally, what is the temperature that is asked here? So that RMS speed increases by 3 times. So what? Suppose initial RMS speed, let it be V. Then the final RMS speed, let it be V plus 3V. But why like that? Why V plus 3V? It is increased by 3 times now. So that means if initial is V, then V plus 3V is the final. So here we have 4V as the final RMS speed, and this is the initial is V. Now we know that RMS speed or RMS velocity proportional to square root of Kelvin scale of temperature, square root of absolute scale of temperature. That is V1 by V2 equal to T1 by T2, and you can calculate. So V1 is first one V, V2 here 4V. So V by 4V equal to root of T1 by T2. The temperature minus 50 means you can calculate here, and this T1 T2 you can substitute, and finally T2 or final temperature we need to calculate. We will get it as 3295 degrees Celsius. But all of you here, first T2 you will be getting it in Kelvin. After getting it in Kelvin, you subtract 273. You subtract the 273. Why? Because see here, one is given in Kelvin. The second, third options are given in Kelvin. First and fourth options are in Celsius. So you get T2 value in both Celsius as well as Kelvin. You calculate. Then finally we'll be getting are the options which we can match are the options are 3295 is the final temperature in degree Celsius, that is only matching with the given values. So key you can conclude it as a 3295, that is first one. So here this calculation you can do T1, what you are supposed to do, 273 minus 50, here you can substitute, and a T2 you can find out, and whatever T2 value you are getting, you obtain it in Kelvin, check with this second one, check with this third one. So if they are not matching, again you convert it into Celsius by just subtracting 273, then you will be getting it as 3295 degrees Celsius. So we'll proceed to the next question, all of you. Yeah, see here, a bullet is fired from a gun at a speed of 280 meter per second. The bullet speed 280 meter per second. In the direction 30 degrees above the horizontal, means something like this. The bullet is fired making an angle 30 degrees with horizontal. The bullet is fired in this way. So this is a path, as you know, it undergoes a parabolic path. It's a oblique projectile. So now the maximum height attained by the bullet is, the maximum height attained, you can use this formula, u square sin square theta by 2g. This is the maximum height formula for oblique projection. So here you can substitute the initial speed 280 into 280 into sin square 30 degrees is the angle of projection, 2 into g value they gave 9.8 in the paper, and sin 30 no need, but still it is given 0.5, or you can take 1/2 whatever. So you can simplify this straight away, direct formula based, maximum height attained you can calculate. If you find it is around 1000 meters, you are going to get. So key we can conclude it as 2. Second option is the correct one, that is the key, second option, and formula u square sin square theta by 2g. So sin 30 1/2 or 0.5. So we'll proceed to the next question. Key is 1000 meters. The amount of energy required to form a soap bubble of radius 2 centimeters from a soap solution is dash. Given surface tension of the soap solution is given. So let us see. As we know, a soap bubble has two surfaces or two membranes, two surfaces. So the surface energy or the work done, or the surface work done in forming a soap bubble, or surface energy of the soap bubble is 8 pi r square t. That is actually surface energy or energy required is T into delta A for one surface. So T into the formed area, surface area is 4 pi r square. But we have two layers, two membranes of soap bubble. So here we take 2T. That is two surfaces, 2 into 4 pi r square. So finally it is going to be 8 pi r square T. Straight away you can substitute the values in this. So the energy, amount of energy required to form a soap bubble is 8 pi r square T. That is the radius, it's given 2 centimeters radius into T, not for temperature, T for surface tension, or the surface tension is 0.03 SI units. So you can simplify this and you can get the exact energy value, the energy, amount of energy required to form a soap bubble you can find out. And say here you will get it as 3. After calculation you will get it as 3.01 into 10 power minus 4 joules you will be getting. So key or the option you can mark is the second one, 3.01 into 10 power minus 4 joules. That would be the key here. So we'll proceed to the next question. all of you? Yeah. In this question, if you can see, yes, in a hydrogen spectrum, the shortest wavelength in Balmer series is lambda. The shortest wavelength in bracket series is how much? That's the straight away. That's the question. So let us see here. 1 by lambda equal to R of 1 by n1 square minus 1 by n2 square. This equation you can use for finding the wavelength in the spectrum, hydrogen spectrum, the wavelength of the radiation emitted in hydrogen spectrum. But here, let us do it in a very simplest way. So this is the possibility, like E equal to Hc by lambda. Basing upon this, lambda is equal to Hc by delta E. That is the change in energy when an electron is shifted from a lower energy level to higher energy level, and again when it de-excites from some higher energy level to lower energy level, there is a radiation emitted. This everybody know that this emitted radiation, when electron jumps from high to lower energy level, that emitted radiation has a wavelength lambda which is Hc by delta E. So when lambda is minimum, that is the requirement in the question, then delta E should be maximum, no? Means the energy difference delta E, this should be maximum. Maximum means what can be that maximum? क्या हो सकता है? What is the maximum energy difference? What is the possibility? So the maximum energy can be from difference from infinity to lower. Suppose if it is say Balmer series, then for Balmer series, we know that the lower energy level to which electron can shift, can jump, that n1 can be, say, first Lyman, then Balmer series. So n1 to n2 infinity I am taking. Why am I considering the de-excitation from infinity to second level? Because that is a maximum possible energy difference. Why energy difference has to be maximum? Because when energy difference is maximum delta E, then lambda wavelength should be minimum. They are inversely related, least wavelength. So lambda minimum. And next one is for bracket series. For bracket series, similarly, what you can conclude, n1 is 4, n2 infinity. Okay. So now here clearly 1 by lambda minimum equal to R of 1 by n square. N to infinity only, n to infinity and infinity. So what you can say, lambda minimum equal to this 1 by lambda minimum. So lambda minimum equal to n square by R. Means lambda minimum proportional to n square. It is directly proportional to n square. So you can see first here n square, this is 2 square, and here it is 4 square. So lambda by lambda dash or lambda 2 equal to n1 square by n2 square, that is 2 square by 4 square. So here you have 4 by 16. So 4 by 16, that is 1 by 4. So if we cross multiply, lambda 2 equal to 4 lambda. You can just cross multiply 4 lambda, lambda 2 into 1, lambda 2 equal to 4 lambda. So the option is 4 lambda means key has to be 1, the option has to be 1. And what did we do here? Just a proportionality relation I framed. Instead of using this equation for 2 times and relating, you can do simply using this. But all these things, this is nothing but the idea behind why we are taking like this. Like if energy difference is maximum, lambda is minimum, that is the concept here. So 1 by lambda is R of 1 by n square, where n here stands for the lower energy level to which electron shifts or jumps. So this is the lower. Higher energy level is infinity here, infinity and infinity, for which energy difference is maximum, lambda is minimum. We will proceed to the next question. Let a wire be suspended from the ceiling and stretched by a weight W. Attach it at its free end. The longitudinal stress is required. So longitudinal stress is force per unit area. Either it can be a, here in this question it can be a tensile stress. Why? Because we are trying to elongate the wire. So force per unit area, force is weight acting on the body, area is A. So key is 1. So here absolutely again, one more time, straight away direct question. There is no need of thinking, no need of any calculation. If you know the formula, that is enough. Force per unit area, that is W by A. That's it. Next question. The angular acceleration of a body moving along the circumference of a circle is dash. So do you remember angular acceleration? It's a vector quantity, it's an axial vector. So axial vector in the sense, suppose the object is rotating this way with some angular acceleration alpha. It's a rotational variable which is a vector quantity, and the direction of such rotational quantities can be expressed with the right hand thumb rule. So this is the way how you can calculate. So if suppose the body is rotating with a constant with a angular acceleration alpha in a say anti-clockwise direction, then curl the fingers this way, then thumb indicates outside, out of the plane. So it is along the axis, out of the plane. Suppose if the same body, if it is rotating in clockwise sense, then you can just curl the fingers this way and the thumb indicates inside, so it is into the plane, again along the axis of rotation. Alpha direction is along the axis of rotation. So here it is along the axis of rotation. Key is 3, along the axis of rotation. Alpha angular acceleration, omega angular velocity, such kind of rotational quantities, they come under certain vectors called as axial vectors, where the direction is shown along the axis of rotation. But along the axis of rotation they don't move, the particle doesn't move, but still we show the direction to be along the axis of rotation. See here, next question. Two bodies of masses m, 9m are placed at a distance r. So m, 9m are placed at a distance capital R. Okay. So gravitational potential on the line joining the bodies where gravitational field equal to 0. See, straight away it's directly they didn't ask, like where is the point where net field is 0, they didn't ask. They mentioned that at a point net field will be 0. At that point you need to calculate, wherever it is you locate that, at that point you need to find the potential due to both of them. So let us calculate first the zero field position or the null point, whatever. So this is the formula. Actual method is net field is 0 means field due to first mass plus field due to second mass equal to 0, and magnitudes are same, E1 is equal to E2, and substituting G m by r square. It's a long process. Straight away the trick or shortcut process for finding the null point is, I am assuming the null point to be here, or I am assuming a point P where net field is 0 here, and this is at a distance of x away from smaller mass. Then this x can be calculated as total separation d by this heavier mass by lighter mass plus 1. So x equal to d by 9m by m, this is root 9 is 3, 3 plus 1 4. So d by 4. Then this remaining, if x is d by 4, then what is the remaining distance? 3d by 4, no? D by 4 and 3d by 4, total distance is d. So I got the null point. I have located where the net field will be 0, that position, that location I got, d by 4. Now let us calculate the potential. So potential, net potential at that point is the formula for gravitational potential is minus gm by r. Let us use this. So now here this distance is d by 4 and this remaining distance is 3d by 4. So potential due to this mass m at this point P, potential is minus g and mass is m by r. This distance is how much? D by 4. Next minus g. So net potential plus minus G 9M by 3D by 4. But why like this? The reason is potential due to this is Gm by d by 4. Potential due to this mass is minus G into 9m by 3d by 4. Gm by r. Gm by r. Gm by r. So with a negative sign. So now you can calculate it like d by 4. This 4 will shift to the numerator. We can shift it. So minus 4Gm by d minus this one 4G into 9m by 3D, and you need to calculate, you need to simplify. You have to do the LCM and you have to calculate it and get the final potential. The final potential you will be getting it as the conclusion is minus 16 Gm by R. So this D you can take it as R, all of you. D is given as R. So this is R. I am considering it as a D. So this D you can consider it as R. So this will be R by 4 and this will be 3R by 4. So minus 16 Gm by R you will be getting here. That is the key is to second option. Key is to second. This is a minus 16 Gm by R. Next question, all of you. See here, a full wave rectifier circuit consists of two PN junction diodes, a center tapped transformer, capacitor and a load resistance. Which of these components remove the AC ripples from the rectified output? This is a straightaway direct theory based or conceptual question. Directly the answer is key 2, which is a capacitor. So what capacitor does? What is the role of capacitor? This capacitor removes the AC ripples, the fluctuations from the rectified output. So rectified output means, rectification means conversion of alternating current into direct current. So alternating current means how it will be? This is the alternating current. It alters. If we consider a sinusoidal variation, then this is the alternating current. We can represent, we can show. And the direct current means it is without any change. By magnitude, by direction, it has to be constant, or at least by direction it has to be constant. So capacitor role is to remove ripples from the rectified output. So second option, key is to conceptual question. Next 22. A vehicle travels half the distance with a speed v and remaining distance with a speed 2v. Half the distance means s by 2 and s by 2 with v 2v. So the direct formula, shortcut formula or trick 2v1 v2 by v1 plus v2. So 2 into v1 v2 by v1 plus v2, that is 3v. So what are we getting here? So v gets this 1v gets cancelled. So we are getting 4v by 3, that is key. Second one, key is 2, 4v by 3. A Carnot's engine has an efficiency of 50%. In this next question, this is related to Carnot's engine thermodynamics. So efficiency is 50%. So that is 50 by 100, 1 by 2. Source temperature is given as 327 degrees Celsius. That is 327 degrees Celsius. We need to convert it into Kelvin scale also. So 327 degrees Celsius. So 327 plus 273. So 600 Kelvin is the value which you need to use. Source this is the source temperature. Next, temperature of the sink we have to calculate. So what is the efficiency formula? 1 minus T2 by T1, temperature of sink by temperature of source. 1 minus T2 by T1, you can write it like this. So efficiency 1 by 2, 50% means 1 by 2. Next, 1 minus T2 by T1, sink temperature we need to find the sink temperature by source temperature is 600 K. So how much it will be? T sink by 600 equal to 1 minus 1 by 2. So that is 1 by 2. So sink temperature is here you can see sink temperature is 600 by 2. That is 300 K and sink temperature is 300 minus 273. But why are we subtracting 273? Because we got it in Kelvin. So let us check in Celsius. So we'll be getting the answer as 27 degrees Celsius, and the key is fourth. The option is fourth one, that is 27 degrees Celsius. Direct straight away formula substitution, 1 minus T2 by T1, 1 minus T sink by T source. That is the final calculation. Next, in a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at a frequency of 2 into 10 power 10 hertz. So frequency 2 into 10 power 10 hertz. And amplitude, the amplitude E naught is 48 volt per meter. Why? Because electric field component has an amplitude. Then the amplitude of oscillating magnetic field means B naught has to be found. So E naught and B naught. So this is basing upon electromagnetic wave. Given the speed of light in free space is 3 into 10 power 8 meter per second. So now let us write the given information here. B naught equal to E naught by C. What is this actually? E naught means amplitude of electric field. Amplitude means what? This is the electric field component, suppose. The maximum value of electric field. And similarly, the magnetic field oscillating, the magnetic field component oscillating, it has a amplitude. The amplitude is B naught. So this is the relation. Now you can calculate. So if you calculate, you will get it as a 1.6 into 10 power minus 7. That is a B naught equal to E naught by 3 into 10 power 8. So 1.6 into 10 power minus 7 Tesla. We can calculate the magnitude of magnetic field, that is amplitude of magnetic field B naught. You can calculate. See here, next question. The ratio of frequencies of fundamental harmonics produced by open pipe and closed pipe. So open pipe V by 2L, closed pipe V by 4L. This is open, this is closed pipe. So what are we supposed to calculate? Frequency ratio we need to find out. Fundamental frequencies given. So frequency ratio open and closed. First one is open, next closed. Open pipe and closed pipe. So that is V by 2L by V by 4L. So it is say 2:1. 2:1 means first option. Well, because V by 2L and here V by 2L gets cancelled, we will be left with 2:1. Yeah, you can go through the next question, all of you. For a Young's double slit experiment, two statements are given. First statement is if the screen is moved away from the plane of the slit, then the angular separation of the fringe remains constant. The angular separation of the fringe remains constant. That is the first statement. Let us see. We'll analyze it, whether it is true statement or false statement. Statement 2, you can see, if the monochromatic source is placed by another monochromatic source of larger wavelength. Means wavelength when it is changed, what happens to the angular separation of the fringes? So let us calculate, let us conclude this basing upon the formula of the angular separation, So let us calculate. First statement, let us see angular separation. So frankly, angular separation, it doesn't depend upon the screen distance actually. So theta is this theta is independent of this particular distance, independent of capital D. So it is independent of capital D means what? It depends upon only small d. It is independent of D. That's the first statement. So what we can say? If the screen is moved away, then angular separation remains constant. So it is independent of D. Next, theta depends on the wavelength of light used conceptually. So theta depends upon capital D. So capital D and small d means what actually? Suppose this is a slit and this is a slit, and this distance is small d between two slits S1 and S2, and here there is a screen and this distance is capital D. This is the clarity. Of course, you know it very well what is small d and capital D. So the angular separation depends on it depends upon only small d. It is independent of capital D. So therefore, the first statement you can conclude whether it is a true statement or false statement. Next, second statement is angular separation, whether it increases or decreases. So you have to check if the wavelength is changed, if the wavelength of the light used is changed when lambda is changing. So definitely theta depends upon wavelength. So here which statement or which one is correct? So you can see statement 1 is correct and both are correct, or any one of them are correct and one is false. You have to conclude it, you have to analyze it. So first statement is correct, statement 2 is false. So key is statement 1 true, statement 2 is false. So the answer is 1 is true, 2 is false. Reason, what is the reason? Why means this is the reason, and theta depends upon lambda. So this is the reason what we can mention. Angular separation theta, this theta, it is independent of D. So this you can keep in mind. Theta is equal to lambda by D. Clearly in this expression it is understood that angular separation, nowhere capital D is mentioned. It is independent of capital D, but it depends upon lambda. So what happens when lambda increases, angular separation should increase. That is the solution. So that is the concept from where you can conclude the answer, that it is second option. Let us see the next one. Work function for cesium metal, for potassium, for sodium. The work functions are, what is the work function given? 2.14, 2.3, 2.7, all are in electron volts only. But on the metal plate, this metal plate, maybe cesium, maybe potassium, maybe sodium, whatever, if some incident energy is incidenting, or if some radiation falls on this metal plate, this radiation should have some energy. That energy given as a 2.20 eV. Now very clearly this energy fall which is falling on the metal plate, it is compared with this work functions. So the concept is, if the energy incidenting on the metal surface, if it is greater than the work function, then you can expect a photoelectric effect to take place. Clearly, they asked for which surfaces photoelectrons are emitted, means for which surface the photoelectric effect takes place, for which surface electrons are emitted. So very clear, no need to calculate directly, simply easily you can say, anybody can say, cesium. See here, 2.2 energy, EV, 2.14, it is less. So more than the work function energy is, and for this it's higher, so this energy is insufficient. For sodium 2.7 EV, this energy is insufficient. The energy 2.2 is not sufficient to eject an electron. Work function itself is 2.7. So more than this energy has to be, more than this energy should be. So option 4, cesium only. Minimum wavelength or cutoff wavelength or minimum wavelength of a electron accelerated through a potential difference V in X-rays, that is lambda minimum is hc by ev. This is the relation. Minimum wavelength is hc by ev, where V is the potential difference between anode and cathode. So lambda proportional to 1 by V. First one, key one, resistance. Given resistance of a resistor 22000 plus or minus 5%. So this is a question basing upon color coding. So suppose this is a resistor, terminals, and this is a band one, the color one. This is color 2, 3, 4. So this is for digit 1. Digit 1 means what? First digit of the resistance, 22 into 10 power 3 plus or minus 5%. This 5% is tolerance, and this is first digit, this is first digit color 2, second digit color, third one is multiplier, this third color is multiplier. So this is the multiplier. So from the chart of BROY, so from the chart black, so etc. So from the chart clearly it is a 10 power 3, that is orange. So for orange band, for orange color, the color coding is 10 power 3. So n is equals to 3. So this is 3. So orange. But how do I know that it is orange? Means 10 power 3. 10 power 0, one color. 10 power 1, one more color. 10 power 2, 10 power 3. So 10 power 3 is for orange. So the list, as per the list which you all know, as per that we can conclude that this orange color has 10 power 3 as a multiplier. This is the tolerance, 5% is the tolerance. Second option. So here you can see this is a capacitor, AC source, and this AC source, it has a certain frequency, it is operated at certain frequency and certain voltage. Now displacement current, whether it increases or not, we want, and capacitor reactance remains constant or increases or decreases, so we have to conclude those things. So here I is equals to so here what we are writing here is I is equals to E by R, that is Ohm's law. I is equal to V by R. So E naught sin omega t by R. So XC stands for what? XC, capacitive reactance. Capacitive reactance means the resistance offered by a capacitor to the passage of AC current, to the flow of AC current. So XC is 1 by C omega. Here it is, this is 1 by C omega. So C omega goes there. So I is equal, this is in the form of I is equal to I naught sin omega t. So here this is the current. So current, what happens to the current? Displacement current. When omega increases and decreases, the operating frequency omega is 2 pi f. When this operating frequency f increases, omega increases. When omega is increasing, what happens to the current? That is a question. So capacitive reactance also, here only the relation is, they are inversely related. When capacitive reactance increases, current decreases. So which option is suitable? You can clearly mention here. Clearly you can show this displacement current decreases, displacement current increases. So see here, let us conclude. When omega increases, what happens? When omega increases, displacement current is going to increase or decrease. You can see. So displacement current is going to decrease, and key is 2. Why? Because displacement current decreases and capacitive reactance remains constant. Not possible. Capacitive reactance decreases. That is also not possible. Why? Because here clearly XC is 1 by C omega. No. When operating frequency increases, the capacitive reactance, what happens? You can assume. So XC is 1 by C omega. So omega decreases, XC increases. Omega decreases and XC increases, and displacement current is going to decrease. Displacement current is going to decrease. This is the conclusion. So omega decreases, XC increases, and displacement current is going to decrease. This is the answer. So key is 2, second option. Next one, we'll proceed to the next one. Just see the two statements. Photovoltaic devices can convert optical radiation into electricity. That's correct. Because the light energy is converted into electrical energy. Zener diode is designed to operate under reverse bias in breakdown region. Yeah, that's correct. So both are conceptual statements. One is related to Zener diode, which is correct. Zener diode is operated in reverse bias, and Zener diode is heavily doped reverse biased PN junction diode. So it is operated in breakdown region. That's correct. This is correct. So which option is suitable? You can see statement 1 and statement 2 both are correct. That is option. Statement 1 and statement 2 are correct. An electric dipole is placed at an angle of 30 degrees with an electric field intensity of 2 into 10 power 5 Newton per Coulomb. It experiences a torque equal to 4 Newton meter. Calculate the magnitude of charge on the dipole. Calculate the magnitude of charge on the dipole. If length of the dipole is 2 centimeters, okay. So torque P bar cross E bar, or you can mention it as tau equal to PE sin theta. Okay. What is P? Dipole moment, and dipole moment can be written as charge into length of the dipole into field into sin theta. So torque 4 Newton meter. Next Q we have to find out. Length 2 centimeters. Field, I'm converting it into meters. Field, the torque is 4. Field is 2 into 10 power 5. Next sin theta, angle is sin 30, where angle theta is the angle made by the dipole with electric field or dipole moment with electric field. So suppose this is a dipole, this is the dipole moment, this is the field direction. So this is the angle theta, dipole moment or dipole making an angle theta, and this is the relation P sin theta. P stands for dipole moment, which is charge into length of the any one charge. This is minus q, this is plus q. Magnitude of any one charge without taking sign. Magnitude of any one charge into length. Which length? Length of the dipole. So you can calculate for charge. Q can be calculated here. Sin 30, this is 1 by 2. So like this you can find out, and finally you may get it, the charge you will get it as 2 millicoulomb. The charge you can get it as 2 millicoulomb. We will proceed to the next question, all of you. The answer is 2 millicoulomb. Next one, all of you. Next question. So, potential energy of a long spring when stretched by 2 centimeters is U. So, X is 2 centimeters and potential energy is U. So, U by U2, this is 2 centimeters by X2. When spring is stretched by 8 centimeters, potential energy. So, U2 you have to calculate. So, from this what we can conclude is U2 equals to 16U. U2 equal to 16U. Key, third option. Now, U by U2 is equals to x1 square by x2 square. So, 2 square by 8 square. 1 by 16 we are getting. So, 16U equal to U2. Cross multiplication. U into 16 equal to U2 into 1. Light travels a distance x in a time t1 in air and 10x in a time t2 in another denser medium. What is the critical angle for this medium? Critical angle. So, critical angle formula C equal to sin inverse of mu rarer by mu denser. Here for us, rarer medium is air, denser medium is some medium which is given, some denser medium we have. So, rarer is air. Now, the next formula which we can make use is the refractive index of a denser medium with respect to rarer medium is which is sin I by sin r, which is speed of light in. So, the speed of light in rarer medium by speed of light in denser medium. So, this speed how we can write? The speed is displacement x by time is t1. Next, this is t1, all of you. This is t1. Why? Because speed, distance by time, or velocity, displacement by time, t1. Next, in a denser medium, speed is displacement. How much here? X and t1 is one pair, 10x and t2. So that is a 10x by t2. So this is mu ratio. So the mu ratio we have like this. So mu denser by mu rarer equal to x by t1 multiplied by t2 by x by t1, t2 by 10x. So that is x gets cancelled, t2 by 10 t1. This is mu denser by mu rarer. Finally, critical angle is sine inverse of mu rarer by mu denser. So you just revert it, mu rarer by mu denser, you will get 10 t1 by t2. This is the critical angle, 10 t1 by t2. So which option? Sine inverse of 10 t1 by t2. Third one, 10 t1 by t2. Next question. If the galvanometer G does not show any deflection, means what? Here in this branch completely current has to be 0. So completely this branch has to be, you can remove just remove this G and 2 volts. But one thing is for sure, we can conclude that this battery has a potential of 10 volts, applied potential, resistance is 400 ohm, and here this unknown resistance R. Across this unknown resistor, a potential difference of 2 volts is maintained. But how? This 2 volts and this resistance, they are parallel, potential difference remains same. Here 2 volts, here 2 volts across this. If this is 2 volts, then this has to be 8 volts. Why this has to be 8 volts? 10 volts total potential difference. 8 volts plus 2 volts. 10 volts, 8 plus 2. So next. Now, these two resistors are in series. Right? This resistance and this resistance, they are in series. So what? V equal to IR. In series resistance, current is same. Same current flows through both of them. That means potential difference is proportional to resistance. That means V1 by V2 equal to R1 by R2. Potential difference proportional to resistance, I is same. So V1, let us take this 8 volts, V2 2 volts, R1 400 ohm, R2 we don't know. So here 8R equal to 800, cross multiplication, R equal to 100 ohm. E2, second option, 100 ohm. Next question, all of you. Next one. Resistance of a wire at 0 degrees Celsius is 2 ohm, and resistance at 80 degrees Celsius is 6.8 ohm. find the temperature coefficient of resistance. RT equal to R naught of 1 plus alpha delta T. Next, alpha is equals to RT minus R naught by R naught into delta T. This is the formula. Let us use this. So alpha equal to RT minus R naught. RT means 80 resistance at 80 degrees Celsius. R naught resistance at 0 degrees Celsius. So 6.8 minus 2 by R naught 2 into delta T, that is 80 degrees Celsius. So from this you can calculate. So alpha you can get it. So that is the option suitable is 3 into 10 power minus 2. So the option is 3 into 10 power minus 2 per degree Celsius, or degree Celsius inverse, or per degree Celsius. Second option, key to second option. The relation we used here is alpha is equal to difference in temperatures RT minus R naught by R naught into delta T. Next one, a satellite just orbiting just above the surface of Earth. So Earth surface, satellite orbiting just above the Earth surface. So almost the height you can neglect, the height of the satellite you can neglect compared to the radius of Earth. So now density of Earth is given T, G gravitational constant, 3 pi by GD equal to how much? So first time period T equal to time period of the satellite, time period T is 2 pi under root of R cube by GM, or you can say T square proportional to R cube. What is this? Kepler's law. And time period formula 2 pi under root of R cube by GM. So now I'll square it. T square equal to 4 pi square into R cube by GM. So here so now 3 pi by GD represents what? So T square equal to 4 pi square into R cube by G into mass is density into volume, 4 by 3 pi R cube. 4 by 3 pi R cube. So here, if this small r is equal to capital R, this radius small r is approximately equal to capital R. Since h is negligible, altitude is negligible, you can cancel. So here we get this 3 and this 4 gets cancelled. 3 pi square, 3 pi, 1 pi gets cancelled. 3 pi by GD we are getting. So this is equal to T square. So key is the first option is the key. Next question, all of you. Next one. The xt graph of a particle under SHM, simple harmonic motion, is shown. Acceleration at 2 seconds. So here, one method is taking the equation, differentiating it, but it's lengthy. So in a very simplest way, what you can do, at 2 seconds, the particle is at its amplitude. So it is at its amplitude. So x is equal to a. Now acceleration is simply a omega square. Acceleration is a omega square. So amplitude into omega square, and omega is 2 pi by t square. You can substitute here and you can get the acceleration of the particle. You can find out by substituting the value. So amplitude is 1, 4 pi square by t square, time period 8, so 8 square. So like this, and here, why here there is a negative sign? Because displacement is expressed as a sin omega t, sine function. Next, if you differentiate it for twice, the acceleration is minus a omega square. Acceleration is minus omega square x. There is a negative sign. Displacement into omega square into negative sign minus omega square x. So therefore we will get the acceleration as a minus pi square by 16. So that is a T3, third. Next question. So just see here. Radius r is r naught into 0.529 into n square by z. So radius depends upon n square. So here you can see r1 by r2 equal to n1 square by n2 square. So r1 radius of the innermost, that is 5.3 into 10 power minus 11. Innermost means n1 is equal to 1, and next radius of the third allowed orbit, so n2 is equal to 3. So r2 you can calculate. So r2 you will be getting it as 4.77 into 10 power minus 10. So therefore it is key is third one, and concept is r proportional to radius r proportional to n square. So r1 by r2 is equal to n1 by n2 whole square. Ten resistors, each of resistance R are connected in series to a battery of EMF E. So I is equals to E by 10R. Next, second current. Next time these resistors are connected in parallel. So E by parallel is what? R by 10. Why R by 10? Resistance 1, 2, 3, so on. All these resistors are connected in parallel. So the effective resistance becomes R by 10 when 10 equal resistors are connected. When they are connected in series, it is 10R. So I1 by I2, you will get the answer as the first one. So why? Because the current is increased n times. So I1 by I2 is equals to that n, you can calculate, that is 100 you will be getting. Why? Because here E by 10R, here it is 10 E by R. I1 by I2, this one and this one, I1 by I2 if you do, that is 100. I1 by I2 is 100, that is the n value, where n stands for the number of times current is increased. I1 is equals to n I2. The number of times current is increased, n can be calculated as 100.